go. Question 18 type of question. Usually what I like to do is to write out the criteria, right? So let's take a look. So we have workers. So workers one side, W for workers, and the number of days, D for number of days. So we are told that a team of 35 is 8 hours. Sorry, so it's not number of days, it's the time. So time, right? So 35, 8 hours to complete a project. So if 3 workers are transferred to another department before the project begins, how long should the remaining workers work a day to complete the project? Wait, did they say how many days? Is that like kind of green thing flying around? It flew to my hand, then like, phew, then don't fly away, then fly to my head again. Okay, never mind, let's continue. Right, so 35 workers work 8 hours a day to complete one project. Project is one project. So if 3 workers are transferred, so re-transfer 3 workers, you're left with 32. How long should the remaining workers work a day? So we're going to find how many hours, right? So instead of using direct or inverse proportion, you can just work it out this way. I think it's easier because eventually I want, you see, my target is 32. Okay, my target is 32. So how to reach 32? I can take 35. I can take just divide by 35. So for example, 1 worker. If I only have 1 worker, how many hours do I need? I need to times 35, right? Because if it's 1 person, you need to take 8 times of 35. So that's 280. 280. Okay, to complete one project. So now it jumps to 32. So we take this divided by 32. So 280 divided by 32. Okay, the time, because from here to here is times 32. So you divide it by 32. So the answer is actually 8.75 hours. Right, so it's going to take 8.75 hours to finish the same project. Okay, so I don't, for this type of question, I don't use the direct inverse proportion because I find it a bit troublesome, too troublesome. This is faster, this is definitely much faster. Okay, but for part B, you have no choice. You definitely must use the direct inverse proportion, right? So let's see how we do this. So P is directly proportional to Q cubed. So we have the formula P equals to KQ cubed. Directly proportional. So if Q is increased by 20%. Now usually this is the difficult one. So this is what we call the OP. Put an O here. O1. Okay, this is the O. Is it in red? I put OP. Okay, let me zoom in. Zoom in so we can see. So I put an O. That's the OP. But now I need the new P. P new with an N. Oops. N. Okay, the new one. What happens to Q? Q must increase by 20%. Now if Q increase by 20%, what is the new Q? You got to determine that. What is the new Q? If Q increase by 20%.
120.
Huh? 120. Can change in terms of fraction? Easier fraction. 20%. You see what's 20%? 20% is 20 over 100, right? So equals to 1/5. Right? So there's like an extra 1/5. That means Q will become, at first Q is 5 over 5, which is 1 whole. So plus 1/5, so equals to 6 over 5. Okay, can you see that? So you need to work that out. So for P new, the Q will become 6 over 5Q, and this whole thing you need to cube it. Okay, you need to cube this one. because Q is increased by 20%. So a lot of the questions, there are many variations. Sometimes they say increase by 50%, sometimes increase by 100%, sometimes increase by 3 times, 4 times or whatever, right? So it doesn't matter they increase by how much. You just need to note the difference between the old one and the new one. Okay, so the new one is now increased by 20%. Okay, so when we increase by 20%, it becomes 6 over 5. Do you understand this part? Okay, very important. So you need to deduce that. So then we work it out. So K, now 6 cube, 6 times 6 times 6, 216 out of 125 Q cube. Okay, which is also equals to 216 divided by 125. 216 over 125. 216 over 125. 1.728. Okay, so I get 1.728 K Q cube. Okay, when I take 216 divided by 125, I get 1.728 Q cube. Now next you need to observe, you see the O one is KQ cube, right? PO is KQ cube. And here I also have a KQ cube. Okay, which means that this thing is the O one. Okay, so I'm going to write it out. So it's actually equals to 1.728 of P with a O, the OP, PO. Right, so at this point of time I can answer the question. The question is, find the percentage increase in P. Now the new one, this is the new one, P new is 1.728 times of the old one. One more time, the new one is 1.728 times of the old one. So what is the percentage increase? 1.7. Yeah. One more time. The new one is now 1.728 of the old one. So what is the percentage increase? Okay, the percentage increase, what is the difference? The difference is 0.728 right now. The difference, so 1.728, you take away one whole is 0.728. Then we take 0.728 times 100 equals to 72.8%. That's the answer. Why must what?
Take away the one.
Okay, because one whole is the O, is the old one. Yeah, one whole is the old one. The new one is now 1.728 times of the old one. So how much did it change? It changed by 0.728 times. Alright, so in terms of percentage, it is 72.8%. So far okay? Right, so it doesn't matter they give you 20, 50, 100, you use the same method, right? Use the POP new method, okay? So take a look at the next question.